This question can be very easily solved if you know the properties of combination of thermal resistances. In this question we have 3 steel rods and 3 copper rods connected in the following format. The temperature at this end is maintained to be 100 degrees Celsius and the temperature at end B is maintained to be 60 degrees Celsius. The resistances of steel and copper wires is given. We need to find out the heat current flowing from A to B. So for solving this question, the first thing you should realize is there will be no current through this copper wire. Now an important thing, very important concept in physics and mathematics, and you can use that in many other chapters also, is symmetry. Now by symmetry, there is no biasness on this side or this side. These two nodes are exactly equivalent. Now since there is no biasness between these two nodes, there is no preferable direction for the flow of current either in the upper direction or in the lower direction, due to which there will be actually no current in this wire. This is actually heat current. Therefore there will be no heat current through this wire. Now wire through which no heat current is there, we can remove that wire. So therefore our resultant system becomes like this. Now since in the previous diagram we used that, we removed that wire because when that wire was there, we could not apply the formula for combination of resistances either in series or in parallel. Therefore, after removing this wire, these two wires become in series and these two become in series, and the system of these two becomes parallel to the system of these two wires. Now we can write this system as steel wire of resistance RS here, RCU here, RS here and RCU here. This can be written to be, since they are in series, we directly add them to get this system. This is RS plus RCU. This is also RS plus RCU. Now these two are in parallel. Two equal resistance in parallel give a value equal to R by 2. Therefore this becomes RS in series with RS plus RCU upon 2. This can be seen when there is R here and R here, this becomes R square upon 2R, that is equal to R by 2. Therefore this is RS plus RCU upon 2. Therefore the total resistance of this system can be taken to be RS plus RCU upon 2, that is equal to 3RS plus RCU upon 2. So we now know the equivalent resistance of the system. So the question becomes very easy now. The system's this end is maintained at 60 degrees Celsius and this end is maintained at 100 degrees Celsius. So the heat current in this direction can be directly written to be equal to 100 minus 60 upon R equivalent, that is equal to 40 upon R equivalent. R equivalent as we know is equal to 3RS plus 2RCU upon 2, that is equal to, the 2 goes in the numerator. This becomes 3 times by 46 plus 1 upon 385 into 1000. This is the value of heat current. On solving this, we get the value of the heat current to be equal to 1.08 watts. So final answer for the heat current comes out to be equal to 1.08 watts. This is a pretty simple method which you should always use whenever there are 2-3 resistances in parallel or series. Combine them to find out the R equivalent and then find out the heat current. Just by using the formula, the heat current in this direction will be equal to T2 minus T1 upon R. So this is the final answer that we get, 1.08 watts.